Okay, let's give you guys some more practice. So here, solve this. This whole thing here is given by this red line here, and you've got to solve it for when it equals 5, and the condition is that x has to be in between negative 90 and positive 90. So what that means is, well, look at 5 here. 5 is here. So it would be along here. But the thing is, I've placed a condition where it has to be in between. The solution for x has to be in between negative 90, which is here, and positive 9. Well, positive 90 here. So you see, equals 5. So you've got equals 5 here. So here's one solution, here's another solution, and here's another solution. This point here, by the way, is not within our range. You see, we've got another point here, 5. We've got another solution here. But the thing is, this solution here is beyond negative 90. So really we should have 3 solutions. 1, 2, 3. Okay, so this is just slightly outside of our range. So that doesn't count. So later on we should have 3 solutions. But when given this problem, you won't be given a graph. So this is all that you're given. Okay, so yeah, so press pause and solve this. Okay, so to do this here, visualize as this. You've got one block plus this block equals this block. You're trying to break into the x here. You're trying to get x on its own. So take away 2 from both sides. So you have 4 sine 3 blah 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 here. So remember, you're taking away 2 from both sides. So this would be 3. Okay. So now visualize it as you've got this thing here multiplying this whole thing here. So the first thing to do here is to get rid of this 4. So divide 4 from both sides. So this one here will be sine 3x minus 30, close it off, equals 3 over 4, 3 over 4 here, and then well, here just visualize as this sine bubble here equals 3 over 4. So at the moment, what you're trying to do here is, well, just quickly sketch your sine graph. So this here is 360. Okay, you're trying to solve this equals 4, 3 over 4. So if 1 is here, then 3 over 4 is somewhere here. You see, we're trying to solve this at the moment. So it's, remember, we haven't applied the 3x minus 30 transformation yet. We haven't applied that yet. We are just trying to keep it simple. So it's just a matter of us trying to solve sine of this bubble here. This 3x minus 30 is within that bubble. It hasn't taken effect yet. So it's just like us solving sine of x. Okay. Yeah. This thing inside here, it hasn't taken effect yet. So it's us trying to solve this here. Okay. So don't forget we've got some more over here, and maybe somewhere up here. So our range, we don't care about our range here. Just get the general solution, and then we will think about our range later on. So if you extend this here, there will be another solution here. Well, anyway, so it's us trying to solve this bubble here. Okay. So this bubble here, so inverse sine to both sides, so it will be this inverse sine of 3 over 4. Okay, we will sort out the range and this transformation later on, but at the moment keep it simple. Just find out the bubble equals blah 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 first. So this bubble here equals now you would jump to your calculator here, punch in 3 over 4, well, 3 divided by 4 equals this, and then inverse sine. So this, well, I'm just going to round it off to 49. So the answer here is 49. Okay, the principal solution is 49, but then we can keep on adding 360, add 360, and so on. So we can say 4 equals 49 plus 360n, where n is an integer for the time being. We haven't made our transformation, the 3x here minus 30. We haven't considered that yet, and we haven't considered the range yet. Let's just get the general solution, and then we will sort this out later on. Okay, so we've got this we've got one solution here, and keep on adding multiples of 360. Okay, the other thing that we need to sort out is this solution here. So again, there are lots of ways of doing this. You just develop your own way of doing it. Okay, so I'm going to use symmetry here. So I know it's symmetrical along here. This will be 180 here, this vertical line here. So this gap here from here to here is 49. So I know that this must be 49. Okay, so it's just a matter of me getting this bit here, take away 49. That will give me this. So it'd be 180 take away 49. Okay, so 7 1 1 3 1. So this is our first set of solutions. We've got 1 3 1 also plus 360 n. Okay, so oops, hang on. So this one should be and. So we've got one set of solutions here, and one set here. Okay, for all at the moment is for all n for all n belonging to a set of integers. So this is our solution so far. But then we need to take the range into account, and also within this bubble here, hang on, within this bubble here, there's 30, no, there's 3x, take away what, hang on, so it was 3x take away 30, okay, so it would be 3x take away 30, so now, so this is where we are at the moment. Our next step is to do this, 3x take away 30 equals, let's just concentrate on this set of solutions first, and then later on we will consider this one here. Okay, equals 49 plus 30n. Okay, where n is an integer. So now try and solve x here. So add 30 to both sides. So you will have in effect 49 plus 360n plus 30, and this side will be 3x here. And don't forget, this is a single number. This is something else. Okay, so we can merge this and this together. So that will be 79 plus this thing here equals 3x. You see, the reason why we didn't consider about us transforming this 3x here, squeezing everything inwards here, is because when we are doing this here, we are in effect we are really now taking care of the squeezing part, the squeezing bit. We are really taking care of the squeezing part now. So when we divide by 3 now, we are really sorting it out. We are sorting out the effect that the graph is being squeezed by a factor of 3. We are doing that right now. So by us dividing both sides by 3, that's what we're doing. We're taking care of it. So now 79 over 3 plus this thing over 3. So this will be 120n. Okay. So here this is our first set of solutions here. Yeah. So when you're here, when you're dividing both sides by 3, you are really taking care of everything being squeezed inwards by a factor of 3. Well, anyway, the second set of solutions is this one here. So now we need to take care of that. So it would be, hang on. So let's start again. 3x minus 30 equals second set of solutions equals, remember it's this thing here, 131 plus 131, 131, and then plus 360n. So add 30 to both sides. So this will be 161 plus 360n, 3x. Divide both sides by 3. So this will be x equals this plus 120n. Okay, so this is our second set of solutions, and it won't be for all n. We've got to now. Oops, sorry, hang on. We've got to now. So hang on. So this one here is our first set of solutions, second set of solutions here. But the thing is, now we've got to take care of the range. It has to be in between negative 90 and positive. It can. Sorry, x has to be greater or equal to negative 90 or less than or equal to 90. Okay, so it's us trying. Remember, n has to be an integer. So we could put. Hang on, let me create some space. So we've got two sets of solutions here so far. So remember, n here, and this n here has to be, well, it could be 0, 1, 2, 3, 4. It could be any integer at the moment, or it could be negative 1, negative 2, negative 3, and so on here. Let's try and put 0 into here first. Remember, we are trying to find x in the range of negative 90 and 90. So if we put 0 into here, this whole term here disappears. So we will get 7, 9 over 3 is a solution, and it's within our range. I know that because this thing is within negative 90 and 90. When you divide it by 3, it will be within that range. So this is a good solution here. Put 0 on this thing here. This thing here will disappear, giving you 161 over 3. Now I don't know if this is within our range. So let's jump to our calculator. Clear this. What's 161 divided by 3 equals this. Yep, that's within our range. 54 is within our range. So this is good. Okay, let's try putting well, don't forget n could be anything, any integer. So let's put 1 into here now. So we've got 1 times 160. Well, and then you've got to plus it to something. So this is 1 will be definitely beyond our range of negative 90 and 90 here. Okay. Well, the minute you times this by 1, it takes you to 120. So that's already beyond our range. Let's put 1 into this one here. So again, the minute you times 1 by 120, then it's beyond our range, and then you've got to plus an extra bit here. That's definitely beyond our range. So 1 is no good. So if we put 2 in there, it's going to be even worse. So don't bother putting 2 in there. 3 is going to be even worse. Don't bother putting 3 in there. So let's try negative 1 now. Negative 1 into here. So it will be this 7, 9 over 3. Take away 120. Is that within our range? So let's check it. Clear this. So we are trying to check 79 divided by 3 equals this, and then take away 120. 120 equals this. Well, this is beyond our range. You can see it's just beyond our range. At the moment, it's negative. This whole thing here is our solution here, but it happens to be negative 94, which is beyond our range. So this here is no good. Okay, let's try and put negative 1 into here. So this would be another solution would be 60. Well, it would be this thing here over 3. Take away 120. Let's see if this is. Don't forget, this whole thing here is our solution here. But let's see if it's within our range. So clear it. 161 divided by 3 equals this, take away 120 equals this. Yeah. So this whole bubble here is really negative 66. So hang on, negative 6. So don't forget, this is our solution here, and the solution is negative 66. You see, this is good, and this is good. And then your next task is to put negative 2 into here, and then negative 2 into here. And it turns out that negative 2 will give you solutions that are beyond our range. So we've only got 3 solutions here. You see, this solution here is good, this is good, and this is good. So solution here, solution here, solution here. Okay?